Hi, folks. This is week 2 of Module 5. As we continue on, some of the things I'd like you to consider. One is the incredible breadth of the electromagnetic spectrum. Um, this goes all the way from uh, radio waves that can have wavelengths that are miles long, all the way to gamma rays, which, well, typically gamma rays are produced by transitions inside the nuclei of atoms, and they have energies and wavelengths that match those. So the typical wavelength of a gamma ray is about the size of a nucleus of an atom or smaller. Okay, um, at the but despite this, we only see a very, very tiny sliver of that. Now, of course, we don't see radio waves because to be able to sense those, we'd have to have um, some kind of sense organs that were actually on the order of the wavelength of the object involved. And of course, we couldn't be. I think the lions would have caught up with us a long time ago if we had to drag around radio antennas sticking out of our heads. In any case, and for infrared, uh, I mean, for instance, let's just go to microwave, which is a very uh, high energy portion of the radio spectrum. Okay, I mean, you use microwaves to heat your coffee up. Okay, well, our atmosphere has a lot of water vapor in it. Okay, so microwaves aren't going to transmit very easily um, through an atmosphere that has a lot of water vapor in it. Okay, uh, infrared is also absorbed very easily by water. Okay, water, we use it all the time and to cool things and steam technology and so on and so forth. Okay. Um, but after we get through infrared, there's this very narrow window of frequencies in our atmosphere that can actually reach the ground. Okay, before we get to high enough energies that the light itself begins to interact with the particles that are in the atmosphere itself. For instance, ozone, the ozone layer blocks out a lot of the ultraviolet radiation. There's no point in having eyes that see in ultraviolet, well, in the far ultraviolet, if there's no ultraviolet illumination reaching the ground. If we had ultraviolet vision, we'd look around and we wouldn't see anything. Okay, well, near infrared's a little bit different. I think and suspect, and I don't have any proof on this, I think and suspect that insects often see in the ultraviolet because, well, they don't live very long and their sensory apparatus only has to last a year or two, if even that long. And so it's advantageous for them to be able to take advantage of that. Humans, on the other hand, we have lenses in our eye that actually protect our retina from ultraviolet radiation. They filter out ultraviolet, and so we don't really see that. Um, Beyond ultraviolet, X-rays are attenuated by atmosphere. They will, our atmosphere. We live at the bottom of an ocean of gas, an atmospheric ocean, and just like light trying to penetrate a liquid ocean begins to die off. The X-rays and gamma rays interact with our atmosphere and are attenuated, and they never reach the ground. So, beyond the fact that we really wouldn't want to stand next to a gamma ray light bulb, again, there's no source of illumination for us to be able to see that reflected light from. Okay, well, just something to think about.